All right. What I'm going to talk about in this little mini whiteboard lecture is scales of measurement. All right. So, in whether we're doing correlation or experimental design, we are always measuring something, and that something that we measure is a variable of some sort. Okay? We've talked about variables in terms of the predictor and outcome variables, or the independent versus dependent variable, we've talked about extraneous variables, but those variables come in different scales of measurement. All right, there's different types of variables, and that's what I'm going to talk about. All right, and just remember, the variables are our measures. Okay, so let's talk about the 4 scales of measurement. Okay, so the 4 scales of measurement are called nominal, ordinal, interval, and ratio. Okay, now I'm going to talk about each one separately. Okay, so nominal scale of measurement is a scale of measurement where numbers represent categories and have no numerical value. That's the definition that's in the textbook. It's a basic definition of nominal variables. Okay? They're often called categorical variables because as the definition says, it's the numbers represent categories. Okay? And most anything you're collecting in terms of demographic information in an experiment is nominal. Okay? Such as gender, race, political affiliation, year in school, first, second, third, fourth, fifth, or freshman, sophomore, junior, senior, fifth year, senior. If you were doing a survey of favorite cereal, each type of cereal would be a different category, and there's no real numerical value to any of this. Now, in coding values for your analysis, you may use numbers. So you may indicate in terms of gender 1 male, 2 female, or 1 female, 2 male. Doesn't really matter. Okay, and that number is just used for coding. It doesn't actually represent any value associated with that category. Okay? So it's either one category or not. There's no average gender, no average year in school, no average favorite cereal, no average political affiliation. It's just either one or the other, or one of several possibilities. Okay, ordinal is our next scale of measurement. It's a scale of measurement with numbers that have an order so that each number is greater or less than the other numbers, but the interval between the numbers is not equal, also called rankings. Okay? The classic example of ordinal is finish in a race, first, second, third. Okay? So there's an order to that, first being greater than second, being greater than third. Okay? But we don't know that how much time was in between the first and second, or the second and third finishers. Okay? And it doesn't matter how much difference there was in time. All that matters is the rank, first, second, third. Okay? Ordinal might be your ranking in class, right? So you're top of the class, bottom of the class, somewhere in between. Okay? Piedmont doesn't do a lot with class rankings, but you always hear about that, say at West Point, someone graduated first in their class or last in their class. Okay? So that's ordinal. We can also use that in terms of where people stand in terms of their opinion about something in relation to what science says about something. The rankings in terms of fall football season. So, the team finished first, second, third, fourth within their division. All those things are ordinal data. Okay, interval scales are a scale of measurement that has both order and equal intervals between values of the scale. Interval scales do not have a true zero. Okay? So consider temperature. Temperature is an interval scale. There's equal intervals between 1, 2, 3, 10, 15, 20 degrees. Okay, so each degree is an equivalent, and there's an order to that. All right, with it getting warmer as you go up in temperature and colder as you go down. But there's no true zero. All right, 0 degrees is not the absence of temperature. It's just very cold. Okay. Likert scales are a little peculiar, but they often get put under interval scales. You've may be familiar with Likert scales. You may not. You have, whether you realize it or not, the surveys that you take in terms of course evaluations, that's usually set up in a Likert scale. And Likert scales can be anywhere from usually an odd number, with 0 being a neutral value. 1 might be strongly disagree, 5 strongly agree. It could be 1 to 5, 1 to 7, 1 to 9, just depending on how much, just how refined the researcher wants to get. It's not necessarily equal distance between a 1 and a 2 in a Likert scale, because it's really very subjective in this sense. But researchers will often assume equal distance between each scale in the Likert scale. But we can treat a Likert scale like an interval scale in the same way for data analysis, in the same way we would for temperature, blood pressure, distance, or anything like that. Our final scale of measurement is a ratio scale. It's a scale of measurement where values measure quantity and have order, equal intervals, and a true zero. Okay? And the common example of a ratio scale is reaction time. All right? So it could measure how fast you respond to a text message. All right? That's your reaction time. The phone vibrates, and how fast do you go to check your messages? Okay. We could have you looking at a computer screen, and if you see a little dot of light, how fast you push a button on your laptop. Okay. Reaction time is a very common method in psychological research. Okay. Ratio scales are the most accurate of all the scales, and that's it. These are the scales of measurement. Now, the importance in understanding the different types of intervals, though, is that they determine what type of statistics we use. So we can't use the same statistics for every scale of measurement. It makes it different in descriptive statistics, right? Since you can't talk about a mean when you're talking about nominal or categorical data, you typically use the mode, right? What's the most common answer? All right. So if you took a survey of favorite brand of cereals, the mode would be the one that's most favored by the participants. Okay? And ratio and interval, it makes sense to use a mean. Okay? And but it's also in terms of our inferential statistics, which allow us to determine if there's a difference between our groups. We'll use different types of statistics as well. Okay, so that's it on scales of measurement.